Hi, Financial It. All right, we are going to be starting on those examples I gave you in class. Well, I didn't give them to you. Mr. Andrews or Mr. Bauer gave them to you, or Mr. Temple. Somebody gave them to you. Anyway, this is the first example. Theo deposits $1,500 in an account that pays 1.5% in simple interest. So we are going to be figuring this out. I went ahead and already started it. Go ahead and copy these numbers down. So I figured out my P, my principal is 1,500. My rate as a decimal is 0.015. My time is 3 because it's 3 years. And then I went ahead and wrote down my ending balance because the question is asking how much is going to be in the account after 3 years. So I've already started this and we are going to go to Desmos and I'm going to plug all of this in. All right, so now we are in Desmos and I already have the simple interest formula in there. I went ahead and plugged it in. This is my principal, this is my rate, and that is the time. So the interest earned on that account is going to be $67.50. And then I went ahead and added those two numbers together. Now the one thing that we need to be careful, so we have 1567.5 is our answer. Okay, so when we write down our final answer, the thing that we need to be most careful of is that we're putting that it is, so 1,500 plus 6750 is 1,567, and we are talking about money, so we need to have that zero at the end. We always want to round to the nearest penny. So this is going to be our final answer. Okay, so this one is Maria's depositing $1,850 for 3 years at a rate of 2.16%, and it's compounded daily. What is her ending balance? So when we use this and we put this in the formula, I went ahead and already figured out what my principal, my rate, my N, so that was something that we needed to remember. N, when it's compounded daily, it means it's 365 unless otherwise stated, and we need to write that in. So go ahead and plug that into your formula and hit pause. Okay, so I went back to Desmos and I plugged it right in. I've got 1850 right here as my principal. My rate 0.0216 over 365 raised to this. So my answer is going to be 1973 and 85 cents. And the reason why it's 85 cents is because of that 5 next to the 4. So we need to be careful when we write that. So when we write that down, that should be my answer. So you can see that I rounded right there. All right, let's go on to the next one. Make sure you're copying all of the work down. I did write down the formula just so I had it on here. Okay, so now we are going to be talking about what is this account going to earn? So Rich and Laura are both 45 years old and they open up an account in a savings bank. And they want to gain enough interest by their retirement at the age of 65. So they're going to deposit $5,000 each year into an account that pays a 1.25% interest rate. And it's going to be compounded annually. And then we want to figure out what the balance is. So I went ahead and plugged in the different numbers that we know. So the principal is 5,000 each time. That is what they're going to be depositing each time or each year. And my interest rate was the 0.0125. I had to figure out the years. I had to be a little bit crafty, so I needed to figure out what the difference was between 65 and 45, and that is 20 years. And it's compounded annually, so my N is going to equal 1. So I went ahead and plugged that into the formula, and now we just need to do the calculations in Desmos. Okay, so I went ahead and I plugged in those numbers into the formula right here. Again, I don't know if you noticed that I have put in all of the formulas into Desmos so I would have them. You can do that for yourself if you would like. You can plug them in and then just save it. So I went ahead and plugged this in and I ended up with $814.89. Again, I know to round to 89 because that is the number 2 and it says it needs to stay the same. So if we go back to that, I need to be careful when I'm writing my answers. I am rounding to the nearest penny and I'm using my dollar sign because we're talking about money. So the account balance that Rich and Laura will have when they retire is about that much money, which probably isn't enough to retire on, so they hopefully have another plan. But we will talk about that later on. Okay, so our next example is going to be about Mr. and Mrs. Johnson, and they know that in 6 years their daughter Anne will be attending a state college, and they will need about they will need $20,000 for their first year's tuition. So we are going to be using that present value of a single deposit investment formula. So we know that we're going to need $20,000 at the end of this. The account pays a 1.5% interest rate, and it's compounded annually, so that's where I got 1. And we know we have 6 years to do this. So we're trying to figure out, what do they need to put into the account so that they have enough money? So we are going to plug all of this into Desmos. So let's go ahead and do that. All right, so if we plug those numbers in, we end up with $18,290.84. So Mr. and Mrs. Johnson are going to need to deposit this amount of money into that account so that they have enough money in that account for their tuition. Isn't that crazy that that 1.5% isn't really a whole lot? They're basically depositing the amount. So in 6 years, that one would earn enough. All right, let's go to the next example. Okay, so when I copied over the question for this one, I forgot to change the wording. So we need to do that. So it should say in your notes, you may want to make some adjustments. This was originally a graphing question, but we are not going to be doing that. I just want you guys to practice doing these formulas. So Randy wants to deposit a total, or wants to have saved a total of $200,000 in 20 years. So that needs to be changed. He is willing to set up a direct deposit account with a 1.2% APR that is compounded monthly, but is unsure of how much to periodically deposit. So that's what we are going to be doing. So our balance is going to be the $200,000 that he wants at the end. Our interest rate is the 0.012. It's compounded monthly, so that means our N is equal to 12, and it's for 20 years. So I went ahead and set this up. And then I went in and I'm going to go plug that in to Desmos. So we can do that real quick. So here it is. There is the formula. And then I plugged everything in right here. So you will notice that we took our rate and we divided it by 12 because that's, it's an APR. So that's why you see this kind of thing. All right. So we went ahead and did that here. It's also compounded monthly. So we divided it by 12 again. So when we're done with all of this, we end up with that he needs to deposit $737.74, or we could round that up and say that he should deposit, we could round that up and we could say that he should deposit $738 every month, just to make sure he has that $200,000, maybe a little bit more. All right, let's move on to the next question. Go ahead and hit pause and get your formula set up. All right, so we have Mark who bought a new car, and the total amount he needs to borrow is $28,716 right there. So that is going to be the original amount of the loan. That's what our P is. So that's our principal, or the original amount borrowed. He is taking out a 4-year loan, so my T is 4. And my APR is that 3.12%. So we're trying to figure out what our monthly payment is. So our M is going to be equal to that. So go ahead and hit pause and get this down in your notes, and I'm going to go over to Desmos. All right, so I already have the formula in, and then we just need to type it all out. Okay, so I plugged this into Desmos. Again, this is why I like to use Desmos over my calculator, because look at all of these calculations. That's a lot of things to type in. So once I get everything typed in, I see that my monthly payment, or not mine, but Mark's monthly payment is going to be $637.13. So that's a fairly nice car at $28,000, and he has a pretty decent rate at 3.12%. So that's pretty good, and it's a low, it's a shorter loan. So that isn't terrible, but look how high his payment is. So he's going to have to make a monthly payment of $637.13. So that is all of the examples that I gave you. We will be doing some practice with this, so keep on the lookout in Google Classroom for that, and I will see all of you later. Thanks for watching. Oh yes, I'm going to be a YouTuber, so hit subscribe and the like button. Okay, talk to you guys in person soon.